Hi guys, so we are live again, and today we will be solving the GFG problem of the day. So for today it is make array elements equal. Okay, my mic is getting too much noise, I guess. I think it must be fine now. Hello, yeah. Okay, so we have been given array of n elements. Your task is to find minimum number of increment operation required to make all elements of array unique. Okay, that is, no value in the array should occur more than once. In one operation you can in one operation a value can be incremented by 1. Okay, so 1 2 2 is there, so we can make it 1 2 3. Okay, and like 1 1 2 3 is here, so we can make it 4, like 1 2 3 4 by incrementing either of the ones by 3 times. Okay, so let's see the constraints ones. Okay, array I can pay up to 10 to the power 9, but at most we have like 10 to the power 5 different elements. Okay, okay, so if all the elements of array are equal, let's say, then how many moves we will need? We can increase like 1, then 2, then 3, then 4. Okay, we may need many moves. Okay, okay, so what I am thinking is, let's first sort the array. Okay, now let's realize long answer equal to 0. Okay, now, and then we will have, we'll keep track of the largest element. Okay, so int max will be the last element only, and set of integer hs set, we will include the last element in this one. Okay, and we will iterate from I equal to n minus 2 till I is less than minus 1. Okay, if we have encountered this element before. Okay, let's say we had in this example 2 2. Okay, so we have 2, maximum is 2. So it will be like, we will be incrementing count that's equal to max minus ai plus 1, and max will be max plus 1, or max plus plus. Yeah, and also in this case we will be adding max here, and otherwise we will be adding ai there, and we will be returning count. Let's see this to be count only. Just compile and run. Okay, we have some errors. Let's say this n. Okay, let's write submit it. Okay, so it's not happening anything here. Header is passing or failing. I don't think we have any like infinite. Okay, so for second case, test case only it failed. Mm-hmm. Okay, so let's say try why it is failed. We have area H 7171079. When we sort it, we will get 1777910. So okay. Okay. We can make 7 to 8, but instead we are making it to 11. Got it. Okay, so for any like let's try to like make a new approach here. I think this would not work. Okay, so now what I'm taking is, after sorting, when we found an element that is occurring more than once, we will like go change it to the next greater element that do not exist on the array. Yeah, next greater which do not exist. And how do we find kind next greater that do not exist in the array? I think we can find that. Using this set only, I think we can find that. Let's say okay, now for I and equal to I, if ai is equal to ai minus 1, then we can say that like ai is repeated more than once. So int j equal to ai plus 1 while hs contains j, we will be incrementing j, and alongside we will also be incrementing the count, and we will be adding j to this thing also. How about now? Let's say a custom test case. It was 7171079. The output was 5. No, 11. 11 was my output. Expected was 5, and we are getting 3. Okay. We can make okay, no, 7 so we can make 7 to 8. One move. Now 7 exists in the array, 8 also exists, 9 also exists, 10 also exists. So we must okay, something I missed. We are sorting, okay, and then we are iterating from I equal to 1 to n. Okay, so for 7 it would have gone to 8, and 8 would have been added to the set. This would be this thing. Not right submitted. I think it might get TLE. Okay, it got passed. So let's analyze the time complexity of this solution. It is like sorting and log time and iterating n time, and how much time will this loop can run. like we can have at most 10 to 5 unique elements in the array. So j cannot never exceed 10 to the power like this. The count of time this loop will run cannot exceed 10 to the power 5. So we can say uh, n log n solution only, because this would be order of n only, n plus n you can say, and this would be n log n. So n log n plus 2n equal to that. Asymptotic analysis we can say n log n is the TC of the solution. And okay, let's see some hints and noting unique and okay with the solutions. Okay, yeah, okay, array of I minus 1 for I. Okay, if array of I is less than equal to array of I minus 1, why this will happen? Okay, less than equal to, okay, so we will set array of I equal to array of I minus 1 plus 1. Something similar is there, but solution is also good. Okay, I think there is no Leetcode thing right now. Actually, let's start from 12:30 I guess. Oh, no, we have some daily challenge. Okay, let's solve this also. Minimum time to collect apples in the tree. We have been given a like undirected tree of n vertices, number from 0 to n minus 1, which has some apples in their vertices. Okay, you can spend 1 second to walk over one edge, return the minimum time in seconds we have to spend to collect all the apples in the tree, starting from vertex 0 and coming back to the vertex 0. Okay, we have edges and has apple. Okay, boolean type, like if it if I apple exists or not. We need to find a minimum time in which we can collect all the apples. Okay, we need to collect all the apples, so I think we must visit all the nodes that do contain apple. Okay, so for every node we can like say how much time it will take to collect every apple in the subtree. For example, there is no subtree of 4 and 5, so like 0 time will be required, 0 required, 0 0, and at node 1, like going to 1 will take 1 time, coming back 2 times, 3 and 4, like 2 times the height of, let's say, not 2 times time required to reach the 4th node, plus the answer at this position, plus plus 2 only, like going and coming back. Okay, so everything will be unique now. The nodes number will be unique. Okay. Let's say we build a agency list. We will have array list, and nodes are from 0 to n minus 1. We will add that many empty list to our array list. Okay, now adding the edges. Okay, now we must store like the time required to collect all the apples in the subtree of the ith node, and the answer of 0th node will be the answer. Let's say we run dfs from 0 with parent as -1. So also we will have a map kind of thing, map of integer. or not required, I guess. Okay, not required. We will can simply return it. So static int dfs int the current node and the parent of this node. Okay, so let's say long, not long, and answer will be 0, and for all the neighbors, that is childs basically, width is not the parent. We if okay, say int temp equal to dfs of neighbor and node, neighbor as node and parent as okay, node as neighbor and parent as node. Yeah. So if temp is greater than 0, we will increase temp plus 2 in our answer. We'll return temp. I think that should work. Sorry, we will answer. Yeah. So wrong answers. We are returning 0 only, and this case 0 only, in this case 0 only. Okay. We are never using that thing. What to say? Has apple. Let's pass that also. Has apple. List of the boolean type has apple. Okay, so if it contains apple, like collecting do not takes any time, no? If it contains apple, we will be returning 1. That will be has apple dot get of node will be 1, otherwise 0. As apple, yeah. Now let's try. Still, now we are returning 11. In the case second, we are returning 8. Okay, so from 0 we have been going to 1, then 4. So 4 will return 1. Okay, 5 will return 1. 1 plus 1 equal to 2. Okay, we are considering the going time, but we are not considering the coming path. Okay, now 7, now 5. Only 1 less than the answer every time. Let's see where it loop comes. We are returning let's say 1 from here, 1 from here. Okay, the time required equal to 1 plus 1 plus 1 plus 1 2. Okay, let's also print the things. Print node, and what do it return? Four will be returning 1, 5 will be returning 1, 1 will be returning 1 plus 1 plus 1 plus 1, 4. Yeah, 1 2 3 4. Yeah, 4 seconds are okay, or 4 time minutes are required to collect every apple in the subtree of 1, including 1 also. 3 will be returning 0, 6 will be returning 0, 2 will be returning 1, this will return 1, this will return 1. Oh, okay, sorry, 4. 4 plus 1 equal to 5, and 5 plus 2 will be 7. So 1 2 3 4 5 6 7 8. 8 should be the answer. So that 1 2 3 4 and then 5. We are not considering this edge, coming edge. So if we starts considering, then also it is difficult, and it will take 1 plus 1 plus 2 and plus 2. So it's quite not difficult, I mean, so tricky. Let it be one only. From 0 to 1, then 1 to 4. Okay, should we return answer plus 1 here? And ink. Okay, then we are returning 16. 61. Then we are returning 12. 1, we are returning 1, okay. Like 1, 1. 4 will return 1, 5 will return 1. And at 1 we will have, okay, 4 will return 2, this will return 2, 2 plus 2 equal to 4. Okay, now 4 will return 1, 5 will return 1, okay. That is, from this line we must return 2 and 2, 2 plus 2 plus 2. Okay, for this case and this case we are correct now, but here we are wrong. Okay, if answer is greater than 0, we will be returning answer or return answer. I think this should work. We start to submit it. Okay, we have some wrong answers. Let's move it. So we have to like 0, 1 and 1, 2 and 0, 3 and all contains apples, and we are returning, let's say, we are returning 8 and the answer was 6. Okay, 1, 2, 3, 4, 5, 6. The answer is 6 definitely. So here we are returning like say print here, print it here only. Okay, two. Okay, in this case 2 is returning 2. Okay, 1 in going, 1 in coming. Okay, 3 is returning 2, 1 is going, 1 in coming, but 1 is returning 4, like 1 in going, coming. Yeah, it's 4. 1 will return 4, 3 will return 2, 4 plus 2 will be 6, but what we are returning 8. Why? 2 will return 2. Okay, let's add one more condition. If node equal to 1, sorry, node equal to 0. One, 4, 3, 2, and we are returning answer plus 1. Four plus 2 would be 6, and at last we will be incrementing at most 1 in the answer, so 7 should be returned. But okay, let's move remove this. Now every case is wrong. Here we are returning only one. Okay, it's okay. So we have, why we had 8 there? Okay, so one would return 5, but one should return 4. Okay, but one had returned 5 only. One had returned 5, so answer has been increased by, okay, but one also got. Okay, if the root itself has apple, then we can write -1. Answer would be 1. Neighbor plus answer plus equal to temp, so answer would be 5 and an answer would be 7, then it would have returned 8. Let's say we don't have this line and 0. Still we will have a 0. Okay, I think we are lacking somewhere, and where that I don't know. Okay, so we have been live from last 28 minutes. This question is not hard, yeah. I would not say any question is hard. Every question is hard until it is not like solved. Okay, let's reformulate the things. We will be returning this only. Okay, and say if any node contains what to say apple, then we must include it in our answer. Okay. We must consider everything in our answer, so this should have returned something like a true. I can include this. The time required to go and come back again. Okay, so if for 1 we are going correctly, then I think we are good. For 1 we are returning 5. That should not be the case. For 1 we should return 4, and if 4 is there, like anything greater than 0 is there, we must go to there and come back. Like we are back again to the initial thing. No, but what to say? 1 is returning 0 and 2 is returning 1. For this is the test case 1 only. Just want this condition. So returning 1. Okay, because it had the thing. Since it had the thing, I'm getting quite confused here, but let's try it again. It should not return 1, instead it should return. Okay, let's say we have this of array type. We'll be returning the 0, and in the first position we will always return whether to consider this or not. Okay, it will be 0. We will temp array 0 plus temp 1. If this not to be considered, we will return a new integer. That will be answer, and either answer should be greater than 0 or this node should consider consist of apple. May throw some compile errors to the temp of 0 plus 2. Now everything is correct. Okay, you got it correct. And we beat 85% of the submissions also. Okay, so problem was quite good, I must say. Okay, so that's for the stream. It's already, I think, some 35 minutes. Thank you for tuning in.